Okay, so at this point, hopefully everyone has managed to run all of the dice simulations. Now, something that I forgot to mention, I'm going to go back and tell you about right now. So here, I forgot to talk about this column, right? So every time that you roll the die, you're actually letting time progress by 2,000 years, okay? And that's what this column is here. Now, the next step of the assignment is going to ask us to plot the data and create that radioactive decay curve that we expect. So on the x-axis, we're going to have time, except instead of half-lives, we're actually going to use this column here, and we're going to plot time in number of years. And on the y-axis, instead of the percent parent remaining, we're actually going to plot the number of parents remaining. So just a little bit different from the other plots that we've looked at. Okay. Now, other things to mention. So if you were filling this out and you got all the way to the bottom and you still had some parents left, that's okay. You can just stop at that point. On the other hand, if you were filling this out and you got to a roll where you didn't have any die land on 1, right? So no studentium was created during that time period, that's okay. And you're going to want to put a 0 in the category for number of daughters removed and just retain the number of parents that you have and re-roll. Okay, it doesn't mean that you don't record that time step, you still do. You just didn't have any daughter created during that period. That's okay, because at the end of the day, this is all just going to average out and give us a nice decay curve. So to plot the decay curve, we are going to plot the number of years on the x-axis versus the number of parents remaining on the y-axis. So you can do that on the provided page, right? Or it's probably easier to just go ahead and run over and do that in Excel. So I'm going to do mine in Excel. This is what my data look like. Yours will be different. Yours should not be the same as mine. But here's mine. And the first thing that I'm going to do is add the plot. So highlight the data, insert, charts, scatter. All right, beautiful. Now I'm gonna go ahead and add axis titles while I remember. So this is time, years, and this is actually number of parents. Now the next thing to do is to add a trend line, and we really want that to be exponential because we know that these decay curves do show an exponential decay. So if I highlight the data, right click, add trend line, I go over here and it's not letting me do an exponential. Well, that's because I, at the end of my data set, ended up with 0 parent atoms left. And a true exponential decay gets closer and closer to 0 without ever actually hitting it. So what I can do for the purposes of plotting is to just erase, delete this last number, delete that 0. And now, if I go to the trend line, it should let me click exponential. Okay. Now the other thing I have to fix is that this trend line is just doing its best to fit all of the data, but we know for a fact that we started with 50, no matter what happens, and we want to force the data, force the trend line to agree with that number. So to do that, I can go over here. I'm still in the trend line part of the Excel, and I'm going to actually set the intercept, set the y-intercept to be 50, because I know that we started with 50 atoms, and I want that to be shown on my decay curve. So now I have this beautiful decay curve, and that's what I'm going to use to answer the rest of the questions in the activity. I'm not going to worry about the fact that these sort of numbers are not really falling on that line. That's okay. It's a random process, so a lot can happen. But you can see that for the majority of time that we ran the simulation, it very, very well is a very good fit to exponential decay. Now, some of you might get a better fit than me. Some of you might get a worse fit than me. That's okay. The important thing is just to recognize that this is your decay curve. Now, to bring this back into the way that we've been talking about radiometric decay with half-lives and such, we probably want to figure out what the half-life of this atom is. And so to do that, I'm going to add some extra grid lines to my X and Y axes. So I just clicked add minor grid line, but I'm not super happy with this. I need, because there's too many of them for my purposes. So if I go back in and I format the axes, this should let me select how much difference my minor grid lines are, and I actually want them to be different by 5, okay? So now I've got 50, 45, 40, 35, etc. for my number of parents. Now I'm going to add some minor grid lines on the x-axis. Excuse my dogs as they go crazy out the window. Okay, these ones are fine. So I just again added the minor grid lines for the x-axis. Those are in 1,000 increments, and I'm actually okay with that. So now, if I want to figure out what the half-life of greyhoundium is, well, that would be the time that it takes for those 50 parent atoms to decay into only 25 parent atoms. And I'm going to be careful to use my trend line to answer that question, not the individual data points. So this was 100% parent. If I go down to 25, that's 50% parent. And you know what? I'm going to go ahead and add a line there just to highlight it. Now I can more clearly see that 50% parent line where there's only 25 atoms of greyhoundium, and that means there's also going to be 25 atoms of studentium at this point. And it looks like the time it takes for my sample to fall to that level is about 6,000 years. So that would mean that the half-life of greyhoundium is 6,000 years. Now, you are going to get a similar answer to mine. It might be a little bit off, that's okay. The important thing is that your answer agrees with your graph, okay? So once you finish your lab, you are going to need to add this graph to the assignment. So you can either do a screenshot or save it as it is and upload it, or connect it to the rest of the assignment and upload it all as one. Okay, so hopefully that's enough to get you through the rest of the questions about greyhoundium and studentium. I will have one more video to walk you through the very last question. Good luck.